Hello and welcome back. Okay, so I appreciate it's over a week and a half since you've last seen a CPU build video, but I have not been idle. In fact, what I've been creating is this. Now this is the PCB for the transfer register. Unlike with a lot of the other PCBs I've done, where I mostly used the auto router, this is the first PCB that I had to hand route the entirety of to get it to all fit and work. So I am very proud of this, very pleased, and I'm looking forward to getting it. That's all been ordered now, so hopefully in a couple of weeks' time I shall have that PCB. Now that's the transfer register and it goes here. And when we've got that in, it changes everything. What the transfer register does is it gives us a route of communication between the 8-bit half of the processor here and the 16-bit half. This is where the GPRs and all the mathematical operations get done, and the 16-bit counter address registers deal with memory access. And so once we can tie those together, we're well on the way to being a fully functional processor. In fact, repeatedly throughout this build, I've kind of felt, hey, this is progressing nicely, I must be quite close to being Turing complete. And I've sat down and I've worked through the list of things that I need to do before I hit that milestone, and it's always been longer than I thought. But this time I've looked at that list and it's not that bad. After this video, the next one's going to be the memory bridge. That connects the main bus here and the memory data bus. So we'll use the control lines that we've got down here to determine when to take the memory data, push it onto the bus, or take what's on the bus and pull it off into memory. At the moment, the only memory reads we've got going on are from the instruction stream via the side access the fetch unit has. Then I need to connect the flags to the pipeline. So that's the 5 flags over here. They will be connecting to the first 5 of the spare control input lines we've hooked up here, and we're pulling them all low at the moment, but once those flags are in there we can implement some interesting behaviors. So then there will be a video on flow control. Obviously I will have to solder up the transfer register once it arrives, and that will finally give me a chance to implement main memory, which will include some writable SRAM. Now along the way, when these 5 bits are done, this processor is Turing complete, which means we can basically do anything that we can fit into the available memory. But there's a few other immediate things to do before I'll consider the core of the processor done. I've got plans to wire in a temporary output peripheral. I need to implement the stack functions. Alongside that, I will do call and return, so we can implement functions and procedures. I'm going to do at least one deep dive programming example. I've got a sneaking suspicion that will probably be implementing a divide operation, but there'll be little bits of programming scattered through the rest of the videos. And once I've got all of that, I'll hopefully put together an execution demo that will impress you. And that's it. That's what I have to do before the core of the processor is finished. Now there'll be a lot of work after that. The rest of this is going to be turned into PCBs, and then these breadboards are going to get recycled into a display output, and there'll be some sound and there'll be some controller input, and then I'll code up a couple of games for it, and then and only then will this project be considered done. The remainder of the video is the PCB design for the transfer register. Now that represented a little over 9 hours of work, but I've edited it down to just over half an hour. So if you're interested in that, watch away. If not, it will be the memory bridge next. Okay, so this is the transfer register PCB, or at least the beginnings of it. Now I want this to sit along the bottom of the current register stack, so that will be underneath the address registers here and the 8-bit registers over here. And so the dimensions are partially constrained. The width is fixed. These control line inputs I'd like to line up with the bottom of the bus control PCB, so that's kind of fixed. And then since I'm using the strip board as my main buses temporarily, it would be good if the bus is all lined up with their counterparts. So the horizontal location of the main bus header here and the transfer bus and address bus are constant. I could move them up vertically if I wanted to, to get some more tracks underneath, but I need to move them up in exact units of these squares in order for the pins to line up with the perf board holes. I've already grouped these up by purpose. So these are the line drivers that put the address onto the transfer bus and address bus. I figure it'd be handy to put these here. I have had a crack at routing this with my previous heavy auto routing techniques, and it's not going to work. I'm going to have to do this manually, so I'm going to record a bit more of it than I might have done otherwise. These are the clusters that handle loads. There's the AND gates for combining the signals. Those are the line drivers to put the lower and upper half back onto the main bus. And that's the line driver I'm using as a bunch of inverters for these LEDs, although that does look quite big there, so I might go back and switch that to a smaller chip. It's only the actual load signals I'm particularly keen on passing through an inverter. Okay, so the standard default clearances here are 6 thou track width and 6 thou clearance. I'm going to turn that down to 5. I'm aiming for 6 on my bus lines, but there's something like a small mathematical error that if I put my grid size to 12 and then try and put 6 wide track next to a 6 wide track, it doesn't work. So that should enable it. Okay, so those are the main bus lines that needs to transport around. Now these tracks are too close together to put a via on, so whenever we need vias we're going to have to kind of ripple a space all the way through. That bus definitely needs to be at the top because it's got to go to the LEDs. Now this connects to this bus input. We could move that up if we wanted to. Let's see if I can route these in to take advantage of the positioning. Might need to nudge it up slightly. That wasn't too bad. Does look pretty good. I did just have a crazy realization that I don't need to keep these lines here straight, so I don't need to worry about overlapping this. That looks really neat, actually. I feel like I'm going to end up with quite a lot of empty space up here, and space is a bit of a premium. Let's stick with this path for now. I think I made a mistake moving all of these over there. Now I can follow the same pattern for these ones. Okay, compared to all of this feels positively wasteful. My only other thought would be if I could get these on their end, but what would I put in the space I freed up here, and these ones would get much more difficult. Let's assume we can get that over there. Nice lot of space for title and stuff there. I think this is going to work. Okay, so we've got all the main bus lines to the outputs done. So that's the line drivers, and I've kind of done a bit of shuffling around on these clusters. Now these are the multiplexers and the latch registers. So this is TL and this is TH. So I think the rough layout of where the chips are is pretty good now. We can see here that these main bus lines need to come into these multiplexers, as do these transfer bus lines, and then these register lines, half of them need to go to the left and half to the right. It's the same as the split over here, so I think what I'm actually going to do is lift these 8 lines up so we start to mirror here what we've got here. And then we'll do something similar here, so we've got 2 bundles of 16 lines going across, which are just the 8 bits of each that are needed for the 2 halves. If it seems like I'm a little more sloppy with the ground lines, it's because I'm intending to do a area fill of ground, and so by putting the traces in, all I'm really doing is confirming there's a path there. I'll worry about the other end later, because otherwise I'm going to end up changing it more than once. I'm going to copy this pattern here. So we've done 2 of the 3 data connections to the multiplexers on this side, and I've got a sneaking suspicion this next step is where it's going to get difficult. I'm sticking these little tabs on, not because I intend to use them on all of the pads, but because if I mouse over the wire, it shows me where that line's supposed to go, but it doesn't do it for the pad. Okay, so this is where we realise it might have been better if we put these chips the other way around. Let's do that on the other side while it still occurs. See if we can do this, because I don't really want to redo all of this work if I can avoid it. Okay, this one could be a little bit messy. Okay, I actually think that's the data lines for TH done. Still got the control lines and there's some power and ground I've got to deal with here. That was less painful than I expected. Okay, so I've done the load for TL. No, that's TH, sorry. So then it's the lower half I need to do. Let's start with the main bus data lines again. What's the right way around for this chip is the wrong way around for these inputs. Main bus done. I'm just going to chuck in some of the power lines so I don't tie myself into a corner with those. I could lift that out the way so it wouldn't be a problem for us. Let's focus on these for now. Right, I'll do the same thing as before, putting some little stubs in here so I can use them to find my way. So I believe that's all the main data lines done, so it's just power, ground and the control lines we need to worry about now. That would be a pretty tenuous ground connection if it wasn't for the ground fill I'll be doing later. Okay, what happened here? That looks like I moved something without realising. That's kind of scary actually. Now I'm having to think about how I want to do the signal LEDs. I think I actually want to do it differently than this. They don't quite fit vertically there. I like them on GPRs and constant register where they're arranged vertically and then I can put the labels next to them. I guess I could put them there like that. It'll give me a massive amount of room. Of course I've got a massive number of blue tracks under here. That just about fits. That was painless. Okay, so I've got 8 control lines to bring across to here. I'm going to remove ground from that bundle. Right, so I'm going to move these lines down enough to fit this little bundle into the bottom layer and get the connections up to here. Now I can extend that as a bus to the left and the right to make all the connections over here and the connections to the LEDs and the couple of control lines that are needed over here. Once again, that looks like it might be a little bit dodgy, but that's going to be a whole big area of copper fill. Now, these thin straight lines are basically showing me which bits of track I haven't routed yet, and I've spent most of this session with a big mess of them on here, and there's quite a big reduction now, so I'm feeling quite close to the end. So these select lines go to the pairs of multiplexer chips, bridge those. Okay, so a bunch of little short traces between the LEDs here. I'm not too worried about those. I'm sure a bunch of people watching this are more expert than me. I would be curious to know how legitimate it would be for me to just do that and just drop a wire in the middle of the pad. Do I risk breaking it with the soldering? You know what? That looks like it's done. And I still want to create the copper areas, and I need to spend a whole bunch of time cleaning up the labels to add some nice labelling for the LEDs down here. I need to mark up what the chips are, because there's definitely multiple chips with the same profile with which are different parts. I'm going to create a nice little descriptor for which parts of the registers these are. Might seem weird me putting these bits of text upside down, but if you see on these, the VCC pin is in the bottom right. These chips are upside down, and if I write the text like that, it might help prevent me making mistakes when I'm soldering it. Okay, let's get a few bits more annotation on. Okay, so a big flaw of putting the extra line driver in front of these LEDs is it's not 100% clear which one is which. I have to kind of trace it. Okay, as the last step, I want to put the copper fills in. Okay, I have to say, having spent all the time hand routing this, I'm a lot less scared of hand routing PCBs now. It definitely takes a whole lot more time, but I didn't feel remotely cramped in this space, whereas with my experience of using the auto router primarily, this felt like I was going to have a lot of trouble. And so I'll definitely be hand routing a lot more in future. I mean, I think I could probably have made this shorter vertically. I had quite a lot of space between some of these big bundles of tracks, so maybe a centimetre or so less would have still been comfortable. Overall, the dimensions of this board are exactly what I wanted because it's vertically the same height as the other registers, and it's the width of the combined 16-bit and 8-bit registers with the bus control in the middle. So this is going to be quite neat in its space on the board. So I'm extremely happy with that, and I'm more proud of this than any of the other PCBs, as long as it actually works when it arrives and I solder it up. Did take a lot more time though. Okay, well, if you made it through all of that, I hope you found it interesting. I hope you can tell I'm getting pretty excited about this now. I'm very pleased with the progress I've made. Part of me never believed I'd get this far when I started the project, but yeah, it's looking good. Okay, thank you very much for watching. Goodbye.